And today's challenge, another BMW, a 3 Series F30 with problems on the high voltage system. Not charging, not holding charge, and discharging itself. Sounds a lot of issues with the high voltage battery. Let's see what exactly is causing all this. Welcome to OGS Mechanics Workshop. Here we fix all type of cars, electric cars, combustion engine cars. Follow me for interesting jobs from our workshop translated in videos. First of all, we will connect to the OBD of the car and we'll run the test on the battery that is fitted on the car. Then we have the option to connect on the battery that is off the car to read data. So before we go to put it on the car, we really want to see the voltage, how good the cells are, how imbalanced, because if there is an issue, we don't want to put this battery only to realize later that is not in good condition. So this is very important and will save a lot of time. But first of all, let's start with the test on the actual car, the battery that is on the car. Harry?
Yeah.
Are we connected?
Yeah.
So let's come over here. I said the problem is that range is very low. Now those cars, they came from factory saying that the high voltage battery, it should give a range of 14 miles. Customer is saying that he probably does 5 or 6 miles, so very, very low. The other problem is the battery cannot be charged to full. So there are two issues so far. And the third issue, customer reported also that while the car was stood in a car park, the battery was depleted itself, so it was coming and looking at the dash, and it was actually zero charge in the high voltage battery. So three things: low range, not charging to 100%, and then discharging by itself. On a scan, shows absolutely no error. So if we are to look at that, it looks like everything is good. So even now we're showing the battery that it has about halfway charge, or a bit more than half. So in theory it should, so it says it does 4 miles, which a bit more than half. It won't do even that. So it's a very low range that the battery can give. But let's see what we're going to read from the battery, if we can understand what's going on and why this range is so low, and maybe what else is causing. So with the tool connected to the OBD, we managed to get into the battery management control unit, and from there we get stats about cells, voltages, and this is a good insight to understand the health of the battery. And what we can see here straight away, so this battery has 5 modules, and each module has got 16 cells, and they are number 1, M1, module 1, module 2, 3, 4, and 5. And some stats come clear straight away. So if you see red is good, here we have amber on the modules and red stats. So what we can see here, first of all, in the M1 we have a cell that is reading 0.4 volts, where all the others are reading 3.8. so that it's definite problem. With such a discrepancy, it's even surprising that it does any range at all. So on the module 1 there's a big problem. On the module 2 there's also a problem, but the problem on module 2, it seems to be the temperature. So it could be that one of the temperature sensor is not reading correct. So if we move into this reading, and here we can see the module number 4, 0.4, and then if you look to move to 6, to number 5, 3.8, and so on, so quite even. And here is the cell that it has a bit of higher voltage, 3.8, but other than that they all quite even, apart from the first 4, so on the M1. And here we get a view of the temperature. So the cell 100 is reading incorrect temperature, so we have more than one issue. And here this is a nice view of this temperature, and here of the voltages. So see, first 4 cells, number 4, 0.4. This is absolutely a big problem. Also, all the other 3 are 2.6, so way below what we should have. What is recommended, a difference no bigger than 20 millivolts. 20 millivolts, and here we have about 3.4, so it's absolutely massive. So because of that, it's gonna lose range. Like I told you, I'm even surprised it has any range with this. So we could run even further test, dynamic test, to see how the battery behaves under acceleration, but having those stats is not even worth doing that, because we know if we are at the stage that the reading were good, we are obviously taking more into it to see more deeper. So under load, what's happening, because it could be that stationary is fine, but as soon as you put load on it, things are going to change, but it's no point. So with this, knowing this, we know the battery is no good. We could potentially strip it and replace the first pack, or see exactly those cells and the one with the high temperature. The other problem is this car, it has 116,000 miles. So I would say it has covered a fair bit amount of mileage, and then degradation on the high voltage battery, it is expected. So since the car has 2 batteries and one in the boot, so we have a replacement one. First of all, we want to read some data out of that, Harry.
Yeah.
And then if we get good stats,
Really?
we will put it in to change it. But I'll let you connect to the other one, and I'll disconnect this. So this is a very good option that we have to be able to read data out of the battery when it's not connected to the car, because it'll save us a lot of time put it on the car only to realize there's an issue. If there's an issue, we like to know now, not after a few hours of work. So let's see. So I can see same thing. So 5 modules, all of them, they look green. Difference between voltages and temperatures are very small, therefore all in green. And it has also a low charge. So if you are to see an issue with the battery, most of the time you'll see it when it's discharged, not when it's fully charged. So it's very good that it's discharged, because if we have those stats when it's discharged, to me this battery looks quite good. And then we can move to the cell status diagram. We can see 3.6, so all 4 elements that were reading very low. And let's have this grid, which I really like. So you see, just a very slight difference, and then it's 4 millivolts. So that's exactly way below 20 millivolts that we want to see. So to me, battery looks very, very good condition. Quite curious to see what range we're having. Temperature also looks good. So I think we have a good battery here.
Yeah.
I think we have a good battery. So happy to move on with it. It might have a low mileage. Obviously, we don't know much about. No, actually, the customer say about 70,000 miles. This is what is being told because obviously it comes from a breakers. But happy to move on.
Yeah.
Replace it. Afterwards, we should be able to code it, and we gonna fully charge. Want to see exactly what range we're gonna do with it. The book says it's gonna do 40 miles. Quite curious how many miles we'll be able to do with the full battery. And then, yeah, we can also run a dynamic test and more test. But for now, we are good to go in the workshop and have the battery replaced. Let's go. With the car on the ramp, we have to lift it up because on this model the battery is located under the boot floor, so that's where we have to get access to see it and remove it. Also, we need to drain the AC gas because this battery is AC cooled. Before we'll obviously can drop it down, 12-volt system, and the service charge have to be disconnected. So the battery actually is in the boot and is not under the boot floor as we initially thought. In here we have the high voltage connector, the AC connector. So those have to be disconnected from under the car. Afterwards, we have to disconnect the attachment, and with the crane, we have to lift this up. What's the battery weight on this one? It's about 80 kilo, yeah. Well, still not very hard, but not very heavy, but heavy enough. And then obviously it's very tight to take it out from there. So we'll use the crane. Yeah. Okie dokie. So soon we'll be able to pull that battery out, put this one in, and then, yeah, move on. We've got the battery disconnected, and now is the time to pull it out. We try to hook it up with the crane. Hopefully we've got pretty much the right balance. Let's go, Harry. Yeah. Okay, we have to pull a bit back. Okay. Oh, brilliant. Let's drop it down. Not that big of a battery or heavy, but it's just the position that it is, the way it's mounted inside the boot, that makes it so hard accessible. Okay, take your hands out. Yes, yes, yes. Whew. It wasn't too bad. No? We're only gonna secure it in a few sections. We want to make sure it works first of all, so we're gonna regas it before we can attempt the coding and literally to connect it, because not even sure if it's gonna need coding or it might work straight on. I'm not really idea. We haven't done an F series yet, but we're going to find out soon. We've got the battery all in connected, and we know the data of the battery cells was good, although the state of charge was a bit low, was 6%, quite low. Now when we scan it, we get some permanent errors that will prevent us from operating the battery as it is with the current control unit. And it's very strange because it's not the first BMW that we see an error in the battery control unit. At some point, a deviation. Although on the live data we could not see anything really wrong, although it was just 6%. I was expecting that it should still be operating. And the next call for us to get rid of the error code and be able to operate the car, the next call was to replace the battery control unit. Now, because we have the old battery and we had no errors in this unit, and also important, they are same part number, we've decided to strip the battery, remove the control unit, and install it into our new donor, our second used battery. And the plan is, it's already been done, and the plan is to put it on charge straight away. We know the control unit that we have there now, it had no errors on that battery. Although with all the problem that the battery had, it had no errors. So in theory, we know the cells are good on this battery. We know the control unit has no errors. We should be able to charge it. Let's plug it in to see. While we doing the AC regas, let's see if this is going to work. In theory, if I'm right, this should work. Yellow and blue, please. It does. Just waiting, because sometimes it takes about 10 seconds and flashback red, but it should not be the case because the battery is good and we had no errors in the controls. So now we're gonna leave it to fully charge, which is gonna take several hours, and then we're gonna run our test, obviously to see the range, see performance on a self-dynamic test and so on. But we are on the right path with this BMW battery replacement. The BM stayed overnight in charge, and this is the color that we like to see. That says the battery is fully charged. We are ready to test to see what range we're gonna get out of this battery. Now, this is gonna also give us the state of health. We can easily calculate like that. So it is the time now. We head over on the road test. What we wanna do first of all, we wanna reset the mileage counter, so know precisely how many miles we are going to do on electric vehicle. So let's see. We're going to set max electric drive. Let's see if we see. So auto max electric drive, no, save. So we want to run only on electric, especially to see exactly how many miles we are going to do with the battery. So state of charge, here's the data. State of charge 95%. We see all the cells in green. Difference between voltages and temperatures is very low, exactly how it should be. And let's see what is gonna happen after 10 miles. Are we gonna get 10 miles out of it? Because it's a used battery, and always a bit of concern with used parts, knowing how good they are. We have data that doesn't look very well. Reading on the cells, we've got a lot of cells that they're reading 0 volts. Now, I'm not sure whether it's a glitch, because I really have nothing on the dash, but the range, he only tells me 9 miles. This is not really good. So I've done 1 mile so far, 1.8, so nearly 2 miles. It tells me it has 9 left. Not sure if we're gonna even going to do that, but the stats here, they don't look good so far. Expected to see voltages from all of them, but looks like one pack it has a problem. I'm more inclined to say here we're gonna have a sensor reading rather than the cell itself, because if we would have one pack with no voltage at all, it wouldn't run on electric at all. So we've got 3 miles done, and it shows 7 more. We're just gonna be on economic, so try not to use anything. We have exactly 10 miles now on electric drive. It shows 0 miles, but we still have a bit of the battery left. Now, my main concern is that module number 1 is not reading correctly. So I don't suspect that module is down completely, but I rather suspect there's an issue with the reading of that. So although we don't really see anything wrong on the dash, mileage is a bit low if we can only do 10, but it still goes on electric drive, so you might do more. But on a data, it's not okay. So what we're reading here is not good, and yeah, needs a bit of checking. But the battery, so far, we do over 10 miles. Let's see exactly how much we're going to do until the battery goes fully down. Alright, so the engine just kicked in. 10.6 miles we've done on a full battery, which is better than what it was, but I was expecting we're gonna be able to do more, um, since the other battery had 160,000, but this one only 70. But there's definitely something that needs addressing before we fully assess the battery's condition. So um, yeah, not straightforward for now. We're gonna go back to the workshop and strip on the module number 1. So we know the problem is on module 1. We have to see exactly, because we have the other battery, we can try to swap over. I wouldn't say to change the module. I would like to change maybe the module um, that measure, because each pack is gonna have a module that measure the voltages of the cells. So I would say I'm more inclined to say there's a problem with that rather than the module itself. But let's see. We have no error codes in the SME, but the strange thing is when we try to read data about the battery, there's absolutely nothing about the minimum cell voltage, maximum, and then the high voltage battery total. So there's definitely an issue. It's, yeah, very strange how this work on. I'm pretty sure on newer cars this would not happen. As soon as there's a difference between cells, the electric drive will stop completely. But yeah, a bit strange on this. See, no error codes. Everything looks good according to this. But if you look deeper into the data, you'll see exactly that is not as good as it says, the diagnostics. So looking in here, looking on the reading codes, you say everything is fine, but we know 10 miles is not exactly what it should be, and we see data that is not correct. So we will strip more to see exactly what's going on. We have now removed the cover on the battery, and our focus is to try to understand what is going on the pack number 1. So this is 1, this is 2, this is pack number 3, this is pack number 5, and below is pack number 4. And our problem lies in here, and here is where we had inconsistent data. Now we've done a measurement on the whole pack, and we have good voltage out of it. We have 58 volts, which kind of, it is what you should be. So it doesn't make sense why we had so many cells reading 0 volts. And furthermore, checking now the car, it looks like everything is in spec. So we have absolutely no problem on all cell status. So all the cells, it's a bit difficult. All the cells have right values now, 3.6, very close to each other. So the problem is not there anymore. And this becomes a bit challenging where the problem is intermittent and we cannot replicate. Therefore, we have to have a solution. And what we're going to do, we are going to swap over components. So we're going to swap over the component, this pack number 1. We're going to put it in the location of pack number 3. And we are also going to swap over the control units. So each pack, it has its own control unit that reads the data from the cells. You can see those wiring here. It reads the voltage and the temperature. So we're gonna put the pack here, the pack from the number 3. We're gonna put it there, and they're also going to swap the control unit at the back with the one from the cylinder from the number 2, and then we're going to test again and see where the problem is going to come back, on which pack, if it's going to come back. Then we'll hopefully make a judgment. We could also potentially replace a pack with the one from the other battery, but the reason that I don't want to do that is because that pack, it has quite a lot of mileage, so different state of health it should have. And then another thing, we have to align the voltages before we do so. So I like as much as possible to work with units on this battery. Hopefully we only going to have an electrical connection, because this is, I'm more inclined to say it's either the control unit or a connection in the plug. We don't know, because now it's not, the problem is not there anymore. So with if we can turn the ignition off, we already have the service, high voltage service disconnected. Is the ignition off? What we're going to do to really isolate the battery, so we're going to disconnect all the orange cables, and BMW have quite a nice system to work on the high voltage. So if we disconnect now the cables, we're basically going to separate each pack from the other, and then like that there's no more real danger of voltage, no more high voltage, and then we can work on doing this swap over. All this being done, those cells are isolated from each other and from having a high voltage current in the battery, and now it's safe to take them out one by one and do the swapping test. Having all the 3 packs out, we're gonna swap them in between, as we said. So this is the pack that was on number 3 before. We're gonna put it on number 1 together with the control unit, and here we're gonna do some swap over also on the control unit. So the point of the exercise is that on the number 1, on the number 1 pack is gonna have all together different control unit and different pack, and we want to see if we can replicate the issue again. Where exactly is it going to come? So hopefully we'll be able to pinpoint whether it's a unit, pack, or maybe the battery control unit itself that has gone down and it gives those false reading. So this is the exercise. We're going to put everything back together and then retest. So this is going to go in number 1. And this is the cell that used to be on number 1. The pack is going to go now. Time to connect all the high voltage cables, and we should be ready to test the car again. All done. The service connector to be put back in. Can you plug it in? what we'll do now, we'll connect to the battery. We want to see data. If the data is going to be correct, we have now good reading. We're going to put the cover back on. We'll put a car on charge. We want to have again a full battery to test again, and then from there more drive test to understand exactly what is going on with the battery. Let's see. Do we have ignition on? Diagnostic data shows okay, but this is our problem. It was intermittent, but we get data from all of them, so it looks all right. We're going to put the car back on charge, and we'll resume after the battery is full again to have another road test and have another set of readings. That's okay. Let's put the cover off on, connect the earth, and we'll move it to get it charged. The car was on charge for about 3 hours. We have a full battery indicating by the green LED. So it is now the time to see what this test drive is going to look like. What's the range we'll be able to have now with a full battery, and whether we're going to have the data coming up correctly on the diagnostics or any more issues. So let's set up in another drive test. We're gonna reset the mileage counter to 0. Yeah, we have now reset the mileage counter to 0 and ready to go. So e-drive, auto e-drive, maximum e-drive, maximum electric drive. This is what we want to see. And then before that, looking at the values, all the cells around 4.1 volts, 12 millivolts difference between them. Spot on, it looks good. Temperature around 28 degrees. So far all looks good. Let's see. An interesting thing, so we now have 12 miles range, so a bit more than initially had. First time you were showing 9 when we start driving, 9 or 10 I think. So it looks a bit better from this point of view. And another important aspect that what I said, driving the car, we couldn't see any errors before without looking at the data from the diagnostic machine. So that's why it's so important, not just what is shown on the dashboard, specifically for a situation like this. So far everything looks good. So we've got 9.5 miles done already. That looks good. Still shows a mile, 1 mile to do with we're obviously running very eco, no air conditioning, no fan, nothing. Good. The value from the battery cells is looking good. Very strange what happened early on. Difference between the cells, 19 millivolts, yeah, 40, depends on acceleration. Temperature 33 degrees. That's within limits. We still have about 20% as it says in here. So 10.3 now. We are on 10.3, 10.4. Still shows 1 mile. That's good. So we actually might be able to go a bit more. 10.7 already. So we are a bit up from what we had before on the first charge. We're gonna turn around here. Let's see how much more we can do. But it's interesting. So it might have been a connection on the module, possibly. But the thing is, the data is there for all the cells now. 11 miles. 11 miles and still show 1 mile. Okay, let's see if we get to 12. If you're gonna get it to 12, I'll be good. Obviously the driving, it's very eco, so no hard acceleration because that will use much more energy. We really want to push it to see as much as possible. 11.4. Now it shows 0 miles, but even last time after it showed 0 miles it still went for a bit. So let's see if we manage to get to 12. Very gentle with acceleration. The engine kicked in. So 12 miles. So we managed to do 12 miles on the full charge. And the stats from the battery, they all look good. So considering we've just double checked, so it is 14 miles that they say this battery does when it's new. So considering we did 12 miles, probably lost about but also another thing is that we've done much better than on the first charge. So it could also be that because the battery sat for a long time, it might need a few cycles before it can be on full capacity. So it might increase a bit more on a few charges. So I would say the battery is in good condition. But even like that, calculating, I would say that probably is lost about less than 20%, so 80 something. But I would say it might increase a bit better, so it might probably go to 13, which is reasonable, very reasonable. And because we have no more data, no more lack of data on the battery cells, I'll say we're pretty safe to put it together. Well, let's see how it gets until we get to the workshop. We set it up on the save battery, so to also charge the battery while we drive. And then if all looks good, we're probably gonna put it together. I'm happy about what we see here. Now we are going back to the workshop, and the drive was good. Ever since the battery went down, we ran the petrol engine. The values on all cells stayed good, all displaying a value, which is good, but very strange why this happened. Anyway, what we have decided to do is to charge the battery one more time, do another road test, and if that also comes well, we're gonna hand over the car to the customer to monitor it and see how it is. But so far we have better stats, we have constant values from the cell, so it looks like we are on the right path to get this BMW ready. Third cycle of charging is now done, and we can see green light here, means the battery is yet again 100% charged. This will be the final test. If the data comes fine, if we can read the data out of the battery all the way through the road test, we'll be all good to go and hand over the car. Let's get in a drive test and see how it's going to behave, the range and the data from the cells. So before we set off in a drive test, we're just going to have a quick check on the stats, reading on a diagnostics, and we can see everything that is within spec. 7 millivolts, the difference between minimum and maximum voltage on cells. All the packs are reading values. We're gonna put on maximum electric drive, and then we have to reset the trip. exactly. So 22 is now down to 0. Let's see what we can get out of it now. We had the AC just a little bit on, and then the battery charge dropped to 93. This the range that the battery gives you is I don't know, it's very low, to be honest. It's a lot of technology for probably little reward, but probably is one of the early ones. The G series is a bit better, so it does about 25 miles. I mean, the book size is about 28, 30, but a good battery does 25. But the F series, yeah, it's quite low. But let's see what we can get out of this as it stands. We are already down to 92%, and we barely drive. We've done 2.7 miles. It still shows 8 miles. I mean, it's a very low count anyways, but we have to see where we're gonna get to it, because initially we had a bit of energy drain having the air conditioning on, and then obviously we want to try to avoid any other worse ways to consume the battery, so we want to have purely drive. So let's see if we can get to past 11, because at the beginning we waste a bit of energy. But the good thing, live data on the cell, is looking good. Today it's actually even a bit colder day, so it's good that we managed to test under a very hot day and also on a colder day. It must have been possibly a connection, since the problem has not returned. Again, it was only visible on the tester. On a dashboard you couldn't see that there was an issue. So we're just gonna drive until the combustion engine is gonna kick in, and we'll then return back. If the data still shows correct, we're gonna be back to fully assemble the car and have it ready to go. But let's see how many miles we'll manage to do with this battery now. We've done about 11 miles actually, so it lost it a bit better than what I expected, and it still show 1 mile. So I think it's yeah, it's quite an improvement from where we started. So we might even be able to get more than 12 miles that we initially got on it. Let's see. But what I'm more interested is to see that we have continuous value from the battery cells. We actually have 12 miles. That's good, considering we also have the AC a little bit on. It's on 0 miles. So yeah, I would say that is kind of good average for the battery, and considering from new they don't have an amazing range. But again, this is kind of ideal condition. So I was very gentle on acceleration. No other consumers on, no AC, no fan, no lights, nothing, which is not really gonna drive like that, especially. And then the weather quite good, because also if it's very cold outside, this is gonna affect the battery operation. So 12.3, and it still goes for a little bit. Okay, and the engine came on. So 12.5 miles we managed to drive with the battery. I think it's we might even be able to squeeze it probably to 13 if we wouldn't had used the AC. But I think it's yeah, it's good overall for what it is for a used battery. Definitely good condition. The BMW is getting ready to be assembled and sent back to the customer. BMW is now ready. After we replace the battery, we read the data. I've got several road tests, and we are happy to hand over the car to the customer. Although the range that the BMW does 12 miles, this is the technology on the F series, but it's obviously a bit better than what it was with all the battery. Obviously, it was quite a worn battery car having over 160,000 miles. Now, the car is operating, it does some miles on electrics. Is it worth the investment? How much did it cost? The customer had supplied the battery to us, so he has purchased the battery, and the battery costed £750. How much do we charge for labor to replace? And obviously the process was quite comprehensive. We've done some tests before. After replacement, we've done an extensive road test. We charged the vehicle twice. We stripped the battery. We swap over the elements because we've seen some data inconsistent. We've seen the module. So we spent a bit longer the time. It wasn't just a straight swap over of the battery. And for this process, we have charged £900 plus VAT. So that is going to bring the total to £1,650 plus VAT. Question that comes in mind is, in how long it will make it worthwhile, the investment, having a longer range. The car was still running, but it's always the risk that at some point, if there is an issue on the high voltage system, you'd be broken down. The vehicle won't work altogether, the combustion engine. So it was not just an investment to have a better range for the high voltage system. It's an investment to have the car running as it should. So this was the job with BMW, where we replaced the high voltage battery, and quite a comprehensive process, I would like to say. If you like this video, don't forget to subscribe to the channel and click the notification button, because very often we have videos with repairs from the workshop. I will see you soon.